Hello, my name is Rasul Nasri and I'm a postdoctoral fellow at Waterloo Institute for Nanotechnology at University of Waterloo, Ontario, Canada. I'm very excited to share with you some of the highlights of a paper I recently wrote for ACS Sustainable Chemistry and Engineering through this Emerging Scholars video. Let's get right into it.
Recently, increasing efforts have focused on the fabrication of hydrogels with either weak or strong adhesion with different biological substrates. However, designing hydrogels with switchable adhesive properties in response to an external stimuli is still a very challenging task. Our objective in this work was to design a thermoresponsive injectable hydrogel with a tunable transition temperature and adhesion for applications where weak to moderate adhesions is required. Our thermoresponsive adhesive is a hydrogel made of chain-end Hydrazide-Functionalized Poly oligo ethylene glycol methacrylate and Dialdehyde Cellulose Nanocrystals. They can form hydrogel through formation of alkyl hydrazone bonds. Remarkable property of this hydrogel is the precise tuning of its thermal transition by manipulating the ratio of hydrophilic OE-GMA300 monomer to less hydrophilic MEO2MA monomer. Upon heating the hydrogel in the probe-tack test, coil-to-globule transition of their copolymer chains occurred due to the change of the quality of water as a good solvent to a poor solvent. By stretching the hydrogel beyond the equilibrium after the coil-to-globule transition, unfavorable exposure of collapsed copolymer chains to a poor solvent led to an increase of the nominal stress and consequently work of adhesion. By increasing the molar percentage of OE-GMA300, which is the bigger monomer, the magnitude of nominal stress peak and work of adhesion increased. Our theoretical calculations also showed that by increasing the molar percentage of OE-GMA300, the required force for extending the collapsed chains into water increased due to the increase of single chain average diameter and solvent-exposed area of the chains. In analogy, it's similar to flying kites in a windy weather. The boy who is flying a big kite needs a higher amount of force to hold it in the wind, and he looks exhausted, while it's easier for the girl who is flying a small kite to hold it and she's pretty happy about it. The key ideas presented in this study will facilitate future development of injectable hydrogels with tunable adhesive properties.